created a model on exponential and logarithmic function, and we are showing exponential and logarithmic function. We are trying to show the applications of exponential functions in different fields of physics, chemistry, and commerce. Like in chemistry, when we calculate the pH values, logarithmic function is like we can calculate it without it also. We don't actually need to calculate it, but using it makes the like it gives a very high value with positive values of x, and it decreases with the negative values of x, but it never touches the x-axis. It shows a x-axis asymptote, and for logarithmic function, its value reduces, and for negative values of y, it almost touches the y-axis, but it never touches the y-axis. It goes till infinity and never touches it. And the special thing about it is when we place a mirror on the xy plane, then holding it perpendicularly, we see that logarithmic function and exponential function are related. In which the mirror image, we see that. And the applications of exponential function is huge. Like we have come so far in radioactive technology, we are creating electricity from it. We have made such big things. We have came so far. And the application of physics from exponential function, we get the radioactive decay formula. N equals to N naught e to the power of minus lambda x lambda t, from which we can calculate how long it takes to decay, like after which time the amount has decayed, how much it has decayed. And it shows that the decay is huge, like it decays so much. But when we come to the half life of a atom, for radioactive atoms, it gets the equation like this: V half equals to Ln2 by lambda. And when we come across this, we know that the half life of a uranium atom is 4.5 into 10 to the power of 9 years, like 4.5 billion years. And we are extracting energy from that to make such beautiful things.
Man has come a long way. Yeah?
Yes.
A virus simulator which works in the principle way. Like it uses SIR based like formulas of maths to calculate if a virus would spread or its growth will be slow. So if you can just use it, it's touch screen, so you can just touch and all tweak all the parameters. Here if I start the model, you can see the virus has started growing. You can pause the model and see how much the virus has grown by zooming on in on it. And if you press one of the virus computer, you can see it's getting you can see how it's spread. Like here you can see it's getting more and more spread. You can see the chain of reaction being built up and how it's getting spread. So here we have some other parameters we can tweak to like change how much the virus should grow, and if we need to like retard the growth of the virus, we need to like add a lockdown. We can just put up a lockdown and the virus will start slowing down. Here in the bottom we have a statistical data, like we have a graph which will show how much the virus is being spread and how long it will take to retard it. On the top, like we can see 4672 are active viruses here on the top. So we can see 4672 viruses are active. Here there is research insights to study. If we like to see the growth of this virus, we can export the data as a CSV file and save it. Here I can just save it.
Scientist. Okay.
So we have taken two sets. Our first set is the first five even numbers, and our second set is the first prime numbers which are less than 10. So if we take a union of these two sets, we will get all these numbers. Here we have to ensure that no elements are related. And next is union intersection of sets. In intersection of sets, we take an element that is common in both of them. So as we can see, only 2 is common here. So their intersection would be 2. And our third step is subtraction. So if we have to subtract A from B, we will remove all elements of B from A. So we will get 4, 6, 8, and 10. One thing we have to keep in mind is that In union and intersection, the order of the set does not matter. You can write A union B or B union A, we will get the same results. However, in subtraction, the sequence of the set matters. If I write B minus A instead of A minus B, we will get a complete different result, which would be 3, 7, and 5.
So, and the fourth one is complement. So, complement just simply means that removing those elements from the universal set. So, if I take A union B here and complement for that, so that would mean that we will remove this from the universal set and we will get 1 and 9 as a result. But if I go for A intersection B and that complement, then I'll get all of these except 2. Since this is A intersection B, so we will remove this from the universal set and we'll get all of this as an output.
So sine waves and cosine waves are nothing but repeating curves, and they are useful in trigonometry, and it helps us to understand the periodic motion like water waves, sound waves, alternating current in electricity.
Now we will talk about congruency triangles. In that, there are a lot of rules, but we are going to talk about mainly 3 rules. One is RHS, SAS, and SSS rule. In RHS, if we take two triangles, their hypotenuse should be equal, and one side and a right angle should be equal. Then we can say that this triangle is equal to this triangle. In an SSS rule triangle, in an SAS rule, if we take two triangles, there should be two equal sides, and the angle which is included in these two sides should be equal. Then we can say that this is equal to this one. In SSS rule, if we take two triangles, all the sides should be equal. Then we can say that triangle ABC is equal to triangle DEF.
So this is a Galton board made by Francis Galton in 1878. So in this model, he showed about how probability can be random. He made this type of model. This is a demo model of him, made by him. When we put marbles in the from the top, we have to make some targets here. So like if like it's a type of game we will be putting. When we put the marbles from the top, we can get some numbers you can we will be getting. So like in this case it has came to +1. So here if we do this in bigger scale, so the Galton showed that it will make a pyramid like a structure if we do this in like a larger scale, but now it is not possible. So and here Galton has used a binomial theorem which show these two formulas he has used in the daily life. We use in ways like to test the IQs of the people and etc.
So basically, it is on coordinate geometry. It is based on coordinate geometry. It has y-axis, x-axis, and origin and plotting the coordinates.